So, hello everyone. I'll be talking about the future of Angular with Ivy today. Now, all of you who are following all the other people who are like really vibrant in the Angular community have been working with Angular for past some time and have been involved with using beta testing and working with Ivy would say this, and you might hear them or read about them saying this again and again, that Ivy is an enabler. So Ivy is definitely an enabler, and we will be seeing what all features does it enable us to have in the near future. So we'll somehow justify this statement throughout this talk. Now, when the Angular team started building Ivy, they had a few design goals in mind, and they classified these design goals into three major categories. It was all about optimizability, incrementality, and flexibility. So we can now see that the Angular builds and bundle sizes have decreased a lot, and that is a result of a few of these things. One such thing is like not generating any metadata files while running the Angular compiler, especially in case of components. So whenever you run ngc, which eventually runs the Angular compiler, um, instead of a few files like the metadata file, the ng factory file, and the ng summary file that it used to generate at the time of the view engine, is now changed to just generation of one file, which is the component.js file. And this file has all the necessary information that this component needs in order to run itself. Now, whenever it is dependent on any of the external dependencies, then it refers to these dependencies by a very clean public API, which is also what the Angular team calls locality. So um, now whenever we run the NGC, which is the Angular compiler, against any of these specific building blocks like the Angular module, the component, directive, service, or a pipe, then it somehow attaches a specific type of static field to the generated JavaScript class file for these particular building blocks. Like for example, in case of a component, it would generate a ﷺCMP static file by calling the theta define component instruction. And this is how it looks like. So this is what the generated code by the Angular compiler looks like for an Angular component. Here we can see that we have a component class, but then apart from that component class, we also have two static fields, which is the theta FAC static field and the theta CMP static field. And then we also have a lot of these other syntax that we can see, which is prepended with a theta symbol. What exactly are these? So these are the IV instructions. And now the whole Angular framework itself is now broken down into many of these smaller and more granular IV instruction sets. What this allows us to do is to break the whole monolithic framework into smaller and more granular specific aspects of the whole Angular framework itself. So there is an IV instruction for each and every specific use case that we might come across in Angular. There is an IV instruction set for DOM creation, which is exactly what we see right here where we are exactly creating the DOM. Then there are IV instructions for data binding, change detection, for generating templates for SVGs, dependency injection, and so on and so forth. What this also allows us to do is tree shaking. So if there is some part of the framework that we are not using, then we can tree shake it off as well. And a lot of this is also somehow a byproduct of locality, as I mentioned. So with locality in place, we can now ship pre-compiled code to npm, and so whenever you change any specific thing in your sources, then um, we can be confident to only compile your sources, because there is no need to actually compile anything related to the third party libraries that you might depend on, which results in faster compilation, builds, and test execution as well. Now, this is a brief overview of what design goals the Angular team, had in mind when it came to working on Ivy. But this talk is not about optimizability and incrementality. This talk is about flexibility. So, throughout the rest of the talk, we will be discussing about a few things that we will be able to do in the near future with Ivy. But before that, let me quickly introduce myself. Hello everyone, my name is Siddharth Ajmera and I'm a full stack JavaScript developer based out in Sydney, Australia. I'm a Google developer expert in Angular, and I write for publications like indepth.dev from time to time. I also have um, two courses on Udemy. This is one of those. It has around 54,000 students enrolled. And just in case you might want to reach out to me, my Twitter DM is always open, and I'm available on Twitter with this handle. So just in case you might want to reach out, come say hi. Also, throughout this talk, I will just be focusing on the things that we can do in the near future with Ivy. But there was a talk that we have already given, that I've given with Martina, wherein we discuss about what actually Ivy is and what all are the things that we can do with Ivy right now. So from now on, till the end of this talk, I will be focusing on what all things that we will be able to do in the near future with Ivy. But I'll still recommend you all to check this talk out. The link to this talk, the recorded session of this talk, is right here. So I'll be sharing the slides at the end, so you can just watch this. All right. So what exactly do we have for the future? I'll be demonstrating this with the help of a few examples so that it's a bit more clear. Now, before I start, I just want to highlight one thing, that Angular modules are linchpins in Angular applications. Now, Angular applications are extremely feature rich. There is a lot that is taken care of by the framework itself. A lot of heavy lifting is done by Angular modules. A few of these things that Angular modules handle are change detection, as well as somehow scoping the declarables that we use in an Angular application, like the components, the directives, and the pipes, and stuff like that. But the whole um, the whole API of Angular and the learning curve that we have when it comes to starting with Angular is still a lot. So the Angular team is consistently trying to make that or flatten that learning curve. And one specific thing that we can start doing is by making modules optional, the Angular modules optional, so that whenever somebody starts, then they don't have to go through the whole modules concept, and they can just start simple with just components. But like I said, Angular modules are extremely crucial. They are the linchpins. So they are responsible for quite a lot of things. And change detection is like one of those major things. But if we don't really use Angular modules and we just want to render Angular components, what exactly do we do? Well, in those cases, these other things that Angular modules are responsible for, we will have to take care of on our own. With that being said, let's start with the very first code example, wherein we will see how we can render an Angular component from scratch without using any Angular module. So I have these examples in stack blids. This is the very first example. Let me just close this file first. Okay, let me restart. Right. So to you, it might not look like a regular Angular project, right? Because we don't have all these different files that we generally see in an Angular project, like the main.ts, and then there is this app folder inside which we have all our sources and assets and whatnot, right? This project or this particular example just have 4 files. It has an index.html, an index.ts, a package.json, and in the dependencies you can just see 4 dependencies here. The very main dependency is Angular core, but these other 3 dependencies, which is rxjs, zone.js, and tslib, are peer dependencies of AngularJS. So even if we don't want them, they will still end up in the dependencies because Angular core depends on it somehow. Now in the index.html we just have this tag which is IV. This can be anything basically, but I've just decided to name this IV. The package.json is also very simple, wherein we have just the dependencies, and ideally tslib should be a part of dev dependencies, but yeah, just for the sake of simplicity I've added it to dependencies section, and that's pretty much it about the package.json. The main thing is actually going on inside the index.ts file. So let's open that up. Now in the import section, you'll see a lot of these theta prefixed functions that I've imported from Angular core. What exactly are these? Well, we have already seen that these are a few IV instructions that Angular uses in order to render things to the DOM. So we have a very simple component class which is named IV component. On this class we have a property called name, and then there is a method called toggle name which somehow toggles the name. So apart from that, we have 2 static fields on it. We have a theta FAC static field which is responsible for generating an instance of this IV component class, and then there is this theta CMP static field which is a result of calling the define component IV instruction, which we see here. Now the define component IV instruction takes a metadata object, which is this, and this metadata object has a few things on there, like the type, the selector. Then there are some declarations, there are some variables and constants, but the main thing to note here is this template function. This is the function that gets called when we want to render the template of this component. And there are 2 if conditions in here. And this template method also gets called with 2 arguments.
Can you increase the size of the editor a bit?
Yeah, sure, I can do that.
The text size.
Is it better now?
Yes, thanks.
Okay, great. Thank you. All right, so let me just quickly explain this once again. So initially we have these IV instructions that we have imported from Angular core, and this is a very simple TypeScript class that has a simple property which is name, and then there is also a method called toggle name. But apart from these 2 properties, there are additional 2 properties which are static in nature. So one of them is this theta FAC static field, which can be considered as a function that needs to be called when we need to generate an instance of the IV component, which is our class. So that's why you'll see that we are newing up the IV component and then we are simply returning it from this theta FAC static field. The second thing is the theta CMP static field, which we are calling, which is a result of calling this theta define component IV instruction. And then to the call to this theta define component, we are passing in a metadata object that looks something like this. Now this metadata object has a few things like the type and the selector and other things of sorts, but the main thing to note down here is the template function. The template function is called when we want to render the template for this component, and it gets called with two things. The first thing is a render flag, and then there is this context. So the render flag determines what specific pass this rendering is going on for, whether it is the whether it is the initialization pass or whether it is the change detection pass. So if the value of render flag is 1, then it would be the initialization pass, wherein it would initialize the template. So while initializing the template, it would run a few IV instructions in order to generate some markup. So for generating the markup as well, we are calling a few IV instructions like element start, element end. Then there might be a text in there which is represented by this text IV instruction. There is also a listener somewhere on the element that is present at the second index, which is a button. The listener is for an event named click, and once this event triggers, then we are calling a method called toggle name on the context. So you can think of context as the instance of this component itself. And the toggle name method is already present on this component class. So whenever the click event happens on this button, then the toggle name method is going to get called. And there is also a text on there which is called change name, which we see right here. And then this element ends as well. So you see a general idea of there is going to be an initialization in terms of how many elements are there in the template. So we can see that there is an h1 element that starts at the 0th index, but on that h1 element there is also a text somewhere. So that is represented on the first index, which we see right here. And then this element ends. The second element starts from the second index, which is this button. There is a click event listener on there, and then there is also a text node present on this button at the third index, and then finally the element ends as well. So this is how the template gets initialized. But what about change detection? Well, I said that the render flag, if the value of it is 1, then it corresponds to the initialization phase. But then if its value is 2, then it corresponds to the change detection phase. So in change detection, what exactly can be done? Well, we can somehow try to interpolate whatever we have as the property. So on the h1, we are binding to the context name, which we have as a property on the TypeScript class right here. This one, right? So if it needs to change, then what we do is we advance to the first index where we have this text node. So remember this one that we placed, this one. So this one is the index, and that text node is present at the first index, which is this one. So we advance to that index by using the advance IV instruction, and then we call another IV instruction in there which is called text interpolate. So if you hover over this, then you can see that it updates the text content with single bound values surrounded by other text, right? So you can use this in order for text interpolation or string interpolation basically. So here it is going to get the updated value of that name and or the initial value of that name, and then it is going to interpolate that onto this text node. So this is what the template function looks like. The final thing that we have in here is a call to a specific instruction which is called the render component instruction. Now, what exactly is the render component instruction is going to do? Well, it is going to take the definition of the component. So there would be a class with its original members, which would be properties and methods that we might have on the class. But apart from that, depending on the class, it would also have other things. Like for example, in case of a component, it would have these additional theta FAC and theta CMP static fields. With that in place, that's probably the only thing that Angular needs in order to render this component. So with that, we can just call the render component IV instruction and then pass it that thing along with a metadata object where we can configure a few things like host. So you can think of host as something on the top of which this component is going to get rendered, which is the index.html host that we had. The name of this tag is IV. So that's exactly what I pass to the host as a value. And with the help of that, we are able to render this component here, as you can see. Now, since I'm having a click listener on this button, which we see right here, as soon as I click on this button, I should be able to see the text getting changed. But I'm actually clicking on the button and the text is not getting changed, right? So what exactly could be the reason? Well, remember that I initially said that Angular modules take care of a lot of things for us. And so if you're not really using Angular modules, then we'll have to do all those things on our own. And change detection is one of those things. So what we can do in this case is here when we are changing the value of the name property, we can call another IV instruction that tells Angular that okay, whenever you are running change detection, you just update this particular value as well. So that IV instruction is markDirty. So I can just call that and then pass it the instance, which is this. And with that in place, as soon as I click on the button, you will see that the text which is getting interpolated here changes, right? So this is the first example wherein we saw that we can just render an Angular component without the help of any Angular module, and we can also detect changes on this component without even using Zone.js. So here markDirty is something that we have imported right from Angular core, so it doesn't in any way rely on Zone.js as such. So that is the first example of rendering component. But there is an issue with this particular syntax, right? So the issue that we see here is that it's extremely verbose because these are a few IV instructions that we have in place, but it's really hard to remember the names of these IV instructions and what they can be used for. Apart from that, we also need to remember uh, the way this whole template is written, right? So even if we somehow miss any specific call to an IV instruction, then things might break, which is something that we don't want. We just want as developers to write something that we are actually used to writing in an Angular component and then let Angular take care of generating all these static fields for us, right? Like this theta FAC and the theta CMP static fields. So how exactly can we do that? Well, that's where something that we have already seen comes into the picture, which is this ngc thingy. So we all know that when we run ngc, then it somehow compiles our Angular application. So during compiling our Angular application, it would somehow transform our sources from the way we have written to the way the runtime actually needs it in order to run, right? So thinking about that and keeping that in mind, we can actually somehow use the compiler in order to do this whole process of generating these static fields so that our Angular component can run without us actually have to manually type all these things for it. So that's when the compiler comes into the picture, and that's what this next tutorial or this next demo is all about. So this is the exact same demo, but apart from the we still have these four files. We have still the index file wherein we have the host. Then we have this index.ts file. In the package.json, you might now see there is an additional entry which is for the Angular compiler, which we will also be able to see in the dependencies right here. This one. So what exactly has changed now? If I open up the index.ts file, you'll now see that we are not importing all those IV instructions that we imported in this first example right here. We are just importing a very small number of IV instructions, which is the ɵrenderComponent IV instruction, the ɵcompileComponent IV instruction, and the ɵmarkDirty. Now, apart from that, we have this metadata object wherein we have a selector and a template. And this looks very similar to the metadata object that we pass to the @component decorator. So we still have a selector and a template in there. And then we just use this metadata as an argument that we pass to the @component decorator. And then on this TypeScript class, we still have the name and the property and the method, but we don't have the static fields like the ﷺ and the ﷺcmp that we initially used to have in the first example. Instead of that, we are calling the compile component IV instruction. So the compile component IV instruction is taking the IV component that we already have here along with some metadata that we have at the top, like the selector and the template. And now the theta compile component IV instruction is now responsible for adding or appending this component class with the ﷺ and the ﷺcmp static fields. And then we can simply call the render component IV instruction just the way we did in the first example right here. So we can actually see the theta compile component IV instruction appending those static fields on the top of this IV component class. So if I open this up in a new tab, let me just open this up right here. And also let me open up the dev tools. Now in the sources, I can place a breakpoint right here where I log the IV component to the console, which is this that I've done on line number 36. So if I try to place a breakpoint right here and reload this, then let's see what happens. So it should ideally break at the exact same line right here. But in the code, you'll see that we didn't really append those ﷺ and the ﷺcmp static fields. But if I go back to this source and navigate to the console, type in IV component and press a dot here, then you will see that there are these ﷺcmp and ﷺ static fields appended on this IV component class. So where exactly did they come from? Well, they came from the call to the compile component IV instruction. And you can also verify that by typing in ﷺcmp on the top of it, which returns us this object. On the top of this object, you can see that there should be a selectors array, and then there should be a template as well, which is a function that takes 2 arguments, and so on and so forth, which is something that Angular is going to then leverage and call to render the component. So this still works as expected. I can still see that once I click on change name, the name gets changed as well. But now everything is happening with the compiler doing all that hard work for us, and us not required to actually code these theta FAC and these theta CMP static fields that we saw in the first example. So this is a more simpler version of the first thing, which is completely developer friendly, right? But this still can be an issue in some cases wherein we might forget to call the theta compile component and the theta render component IV instructions. So what exactly can be done about it? Well, there is a very clever thing that Uri did once. So what he did was that he created a higher order component, or a, or a decorator out of it. And then inside this decorator, what he did is he manually called the compile component IV instruction and gave it the component and the metadata. Now, apart from the compile component, I also added the call to the render component right here. And now if I go to my index.ts file, then I can simply see that there is just this component class that we have with the property and the method. And then this IV component class is decorated with the compile and render component higher order component, or the decorator that we just created. To this I pass the selector and the template, and then that's all it needs to first compile this component and then render it right here. And it's simply returning the component to us. So with that in place, you will see the exact same behavior that we saw in this second example, wherein we have the component getting loaded and change detection working as well. So let's wait for this application to open up. I might just close this one. And yeah, so the application, the component is getting rendered. I can click on change name to also change the value on that particular property, which is great, right? So now at this moment, I'm able to render an Angular component without actually using Angular module. Now I'll just give you around 5 seconds to digest whatever I've shown so far and just realize how great this is, right? Because now you don't really need Angular modules anymore. You can just use these instructions in order to render a component from scratch without even using Angular modules. And this is also great in terms of rendering components dynamically or lazily, right? So we can still do that in Angular 9, but how exactly do we do it? Well, let's say that there is this dynamic component that we want to load lazily. Now, if I open up my app module, then you will see that there is only the app component, the timer component, the sample directive, and the sample pipe added to the declarations array. But on my app component HTML, I have a button that loads a dashboard component lazily. Now the dashboard component is not a part of the declarations array, right? So it's obvious that it's not going to be generated as a part of the main bundle. It would somehow be generated in a separate chunk. So how do we render that in Angular 9 without using these new APIs? Well, we use the exact same thing that we used to do. So this time around we are using the dynamic import statement in order to load that JavaScript module, and then we destructure the dashboard component out of it. Then what we do is we already have the component factory resolver injected as a dependency on our app component. So we call that along with passing the dashboard component that we got from this dynamic import. And then we also have a view container ref. This view container ref is somehow referencing this div element by using this template variable, which is the host for lazy component. So I have a view child that I'm referencing this host for lazy component by, and I'm reading the view container ref from there. So I now have a view container ref on the top of which I can call the create component method and then pass it the factory. And once I get an instance, I can then also assign a few properties that might be present on this component class, which is like this show property. With all that in place, if I check this out, so if I open up localhost 4200, now I can just do that because the app is already running for me. So I see this load dashboard lazily component. This load dashboard lazily button. Now, since this is going to be loaded lazily, what you'll see that as soon as I click on this button, you'll see an additional request going on, and this would download that additional chunk for the dashboard component. So as soon as I click that, the dashboard component chunk gets downloaded and it gets rendered onto the screen right here. And this is an old photo of Dave that we see right here on the screen. All right. But the code that we see here is extremely verbose as well, right? I mean, there is quite a lot of things that we have to do in order to render component with Angular 9 at the moment without using the newer APIs. So this is simplified by um the render component IV instruction that we have seen, because as soon as we get a hold of the component, then we just have to call render component on it and then provide it a host, because this syntax is something that we have already seen, right? This is the render component IV instruction that we call, and then we pass it uh, the the component which has everything on it, and then we also provide it a host, and that's all that we have to do in order to render it. So if there is a second section here wherein I have a button and I call the load component dashboard lazily via render component, which is this method right here. In this method, I'll still have to call the dynamic import statement and then pass it the path of this component where it is present. But then as soon as I get a hold of this component, then I can just call the render component IV instruction and pass it the host, which is like the app dashboard app loaded via render component, which we see right here. So instead of calling these component factory resolver and stuff like that, you just have to call render component, and that's going to take care of everything on its own. You don't have to deal with all that verbosity that we used to deal with. So that is great. Another great thing about this render component is that it also has this host property, and this host property just needs some sort of an element that it can sit on. So you can pass it anything, literally anything, in order to render. So at this moment, I was passing it this app loaded via render component. So let's say that if I wanted to, on the click of the button, call the same method, then I can pass it an argument which would be for the host, and then instead of hard coding the host name right here, I can simply pass it whatever I get from the caller. So if it is called for the first time, then it will give me app loaded via or this long selector name. For the second time, it will give me just anything right here. So with that in place, one good thing about this is you don't have to actually use the exact same selector that we had on this loaded via render component class, which is this, right? So now I will be able to render this component even without using the exact same selector that I had, which is also very great. So if I open this up, then I see two buttons here. If I click on the first button, it will render this component, and then it also loaded this component lazily, right? But now that this component has already been loaded, if I press this button again, it will not create a second request. It will just use the exact same definition of this component that we get from the initial call. So if I click on this, okay, something has broken. So I'm clicking on this, but things are not working. Let's see if I get anything in the console. Nope. Okay. Let me just go back to the template. Okay, let me just reload the application and see if this works. Okay, so I click on this first button. It loads this component. It also loads the definition by making a call. If I click it again, I see the exact same component getting loaded. It was probably an issue with compiling the whole application, because of which it was probably not working. But yeah, now that the application has finished compilation, I see that on the click of both of these buttons, I'm able to load the exact same component, but with using two different hosts. Once I'm able to use this host, which is right here, and then I'm also able to use a different host this time. Also, since this component was downloaded once, I'm able to load that exact same component twice without sending an additional request, which is also great. But what if I wanted to do something like dependency injection? What happens in that case? So let's say, for example, let me just close this HTML so that I have a wider screen. So in this case, we are using, or we are loading this particular component that we see right here. Let's say that on this component, I wanted to inject a data service as a dependency, and then I wanted to make an API call and log whatever I got from that API call to the console. What happens in this case? So let's try doing that. Now I'll click on the load dashboard button. It makes that call to download this chunk for the component, but I'm not able to see anything right here. If I go to the console, I also see that there is an error that says something like inject must be called from an injection context. Now, this is a lazy component that was downloaded, right? So it might not have context of things like where exactly can it inject a specific dependency from. That's why Angular is throwing this error. But the good thing about the render component is that I can also pass it a host. And then apart from the host, I can also pass it an injector. So there is an injector field that I can supply, and I already have injected the injector as a dependency on this component. So I can just pass it that. So the injector for this would be this dot injector. And if I save this, let's wait for it to load. Let me clear everything. Now, as soon as I click on this button, you'll see that there is a network call going on to download the component, there was also this additional API call that was made to the request.in, which loaded this data somehow. And then I go to the console and I also see that data getting logged, which is from this particular point where we logged uh, inside the subscribe, right? So now I'm able to also inject this service as a dependency into this lazily loaded dynamic component, which was the demonstration for. Now I'm done with all the demos, and now you might be thinking where exactly to from here. So, uh, like I said, the Angular team is constantly working on making Angular modules optional, and with that, there is also a proposal by Minco, wherein what if I wanted to use some other specific declarables like a directive or a pipe, right? Because at this point, let's say that instead of using this data service and subscribing to the method, what if I had a user dollar observable, which is of type any, let's say, and then inside that, I just um, initialize that to a call to the get data method. What happens in this case? Well, what I would generally do is that now in the template, I would go and then use the async pipe, right? So let's say that inside a pre tag, I use the async pipe with this user dollar observable, right? So if I save this and go back to the application, and let's also try to load this component. As soon as I load it, I see that the component gets loaded, but then there is an error saying that the pipe async could not be found, right? So right now what's happening is that this component was loaded dynamically. So there are quite a lot of things that it doesn't really know about, right? Like say for example, if we talk about dependency injection, initially it didn't really know about dependency injection, and so we had to pass it the injector in order for it to understand that okay, there is an injector that I can use to inject this service as a dependency. But what happens in case of these other things like the like some other pipes that you might already have in your application, or some directives of sorts, right? So it's probably still not possible, but there is a proposal that was given by Minco. So I'll highly recommend you all to check this proposal out. The link to this proposal is right here on this slide. And what he proposes is that if there are some other declarables, like there is this zippy component and then there is this capitalized pipe, and if I wanted to use that inside my component without using Angular modules, then I could just use a depth array and then pass in all these things that my component might depend on, and it should still work as expected. Now, this thing is still not implemented as such in Angular, but this is just a proposal, and we might see something like this probably in a far future from here. And with that said, thank you all so much for listening to me, and um, please do let me know if you do have any questions regarding this. If you don't have any questions regarding this, and you might get questions after uh, reiterating through the talk, please feel free to reach out to me on Twitter at this handle, and I'll be more than happy to answer any questions that I can. That's it. Thank you.